Hi everyone. In this video, we are going to learn about Azure Load Balancer. And we will do it in the fun way with a full hands-on demo. So a load balancer is a service that automatically distributes incoming network traffic across multiple servers or resources. Its main job is to make sure no single server gets overwhelmed, and it helps improve the performance, availability, and reliability of your application. So if one server goes down, the load balancer sends traffic to the healthy ones, keeping things running smoothly. It works for both incoming internet traffic and internal network traffic, depending on how it's set up. So as always, we will learn by doing. So I won't bore you with too much theory. Let's dive straight into a demo and explore how Azure Load Balancer works along the way. So let me first create two virtual machines. So these virtual machines will be the backend resources to which the load balancer will be directing the traffic to. So let me head over to the virtual machines. I'll click on Create an Azure virtual machine. I'll select my subscription, choose a resource group. I'll name my VM, NeoVM1. I'll select the region as East US itself. As for the availability zones, I'll select as no infrastructure redundancy required. Security type, I'll select as standard. As for the image, I'll choose Windows Server 2019. I'll leave the size as D2SB3. Provide admin credentials. As for the public ports, I will select HTTP and HTTPS. Hit on Next. Select my disk. Choose my virtual network. Subnet and public IP. So we will have the public IP for now, but later on we will be removing it in order to test the load balancer. Select the network security group, leave all the other settings as default. Hit on Next. I'll click on Disable for boot diagnostics and click on Review plus Create. So while this is in progress, I will go ahead and create one more virtual machine. Since we will be using the similar settings, I will directly go ahead and create it. So my deployments are completed, and I will be having two virtual machines in my subscription. As you can see, I have two virtual machines, NeoVM1 and NeoVM2. And both of these virtual machines have ports 80 and 443 enabled, which is for HTTP and HTTPS protocols. What I'll do next is I will be installing the Windows Server Internet Services feature on these virtual machines. So for that, I won't be logging into the virtual machine directly. I have a PowerShell script in place, which I will be executing on these virtual machines through the Azure portal itself. What I'll do is I'll go to the run command feature, which is available for virtual machines. So this feature, we are able to execute PowerShell scripts directly on the virtual machine. And this is a very simple script that I have in place. So what it does is it will first install the Windows feature for web server. and it will add the content which is displayed over here. So our first virtual machine is NeoVM1. So I will display it as this is NeoVM1. This is a standard script, so I'll just copy the content. And the very last command will restart the service to make sure that everything is working. We'll paste the script and click on Run. So while this is in progress, I will duplicate my tab. Go to virtual machines. Let me open the virtual machine 2. Go to Run command. I will open my script, and this time I'll replace virtual machine 1 with virtual machine 2 name. And copy the same script. Paste to the Run command space, and click on Run. The execution will take a few minutes. So the script execution is completed on both my virtual machines. And let me verify that. I will go to my virtual machines. Let me copy the public IP of the NeoVM1. I've tested it in another tab. And as you can see, the public IP for virtual machine 1 is displaying as this is NeoVM1. Let me do the same for the second VM. Copy the public IP, search it under the tab, and as expected, this is looking here as well. It's displaying as this is NeoVM2. Alright, so we have our backend resources in place. Now what I'll be doing is I will go to the network settings of both the virtual machines and remove the public IP association. I'll go to my network interface. Under IP configurations, let me select my IP config. I will deselect associate public IP address and click on Save. Let me do the same for my virtual machine 2. Go to network settings. Network interface, IP configurations. Click on my IP config 1, and I will deselect associate public IP address. Hit on Save. Once that is done, let me refresh the public IP page of the virtual machine. For the public IP, this association was successful. Both the pages are now displaying as countries to this page. Alright, so the next step is to create our load balancer. So in my Azure portal, in the global search, I will search for load balancer and click on Create button. I'll choose my subscription, select my resource group, provide a name for my load balancer. I will name it as Neo Load Balancer. As for the region, I will be creating a regional load balancer, so my virtual machines are in East US region, so I will be giving the same region. So when it comes to this queue, we have two options. One is standard and the other one is the gateway. So the standard load balancer is the one you typically use to distribute traffic across your virtual machines or services. So it's great for making sure your application stays available and responsive by balancing traffic within a region. It supports both public and internal traffic, and gives you more features than the basic version which was there previously and is used for general application scenarios. Whereas a gateway load balancer, on the other hand, is more specialized. It's used when you need to insert third-party network appliances like firewalls, security scanners, or any kind of packet inspection tools into your traffic flow. So it doesn't just distribute traffic, it helps redirect it through these appliances before sending it to your application. Think of it as something you'd use when security or traffic inspection is a key part of your setup. So to sum it up, standard load balancer is used for general purpose load balancing of applications and services, whereas a gateway load balancer is for scenarios where you need to route traffic through security or network appliances. So in our use case, I'll be selecting it as standard because we do not have any network appliance VMs. Coming to the type, we have two, what is public and internal. So a public load balancer is used when your application needs to be accessed from the internet. It has a public IP address and takes incoming traffic from users outside your network, then distributes it to your backend servers or services. Whereas the internal load balancer is used when traffic that stays within your private network. It doesn't have a public IP and only handles a request from inside your virtual network, like between different services or tiers of an application that don't need internet exposure. So a public load balancer handles internet-facing traffic, whereas an internal load balancer handles private internal traffic within your virtual network. So we will be accessing our virtual machines through the internet, right? So I'll be selecting it as public. As for the tier, we have two tiers, which is regional and global. So a regional load balancer in Azure distributes traffic only within a single Azure region. It will manage traffic between virtual machines or services that are hosted in that specific region. It's great when you have an entire application or workload that is displayed in one place. So a global load balancer, on the other hand, handles traffic across multiple Azure regions. It helps direct users to the nearest or most available region where their application is deployed. This is ideal for global applications that need high availability and low latency for users across the world. So basically, a regional load balancer will work within one Azure region, whereas a global load balancer works across multiple Azure regions. So I'll be focusing on regional load balancing since we have all my workloads in the same region as East US. So I'll select it as regional. Click on next. So we need to create a front-end IP configuration. So the front-end IP configuration in a load balancer defines the IP addresses that clients like users or other services will connect to when accessing your application. So this is the public face of your load balancer. You can configure a public IP address if your application needs to be accessed from the internet, or an internal IP address if it's for traffic within your virtual network. So in short, the front-end IP configuration sets up the entry point where all incoming traffic will be directed before the load balancer distributes it to the backend servers. So let me give a name for my front-end IP configuration. I'll select IP version as IPv4, IP type as IP address itself. So if you have multiple domains or multiple ports involved and you require multiple IP addresses aligned to those ports or domains, you can select from IP prefix. Whereas in our case, we'll just go with the normal public IP. I'll click on create new for my public IP. I'll provide a name. I do not require an availability zone. Click on No and hit on Save. We are not using a gateway load balancer, so click on Done. Hit Save. So as discussed, a gateway load balancer is a type of load balancer designed to work with network virtual appliances, and we do not require that. Click on Next. Next, we need to create a backend pool. So as discussed, the backend pool is like a collection of all the servers or resources that the load balancer sends traffic to. These could be virtual machine scale cells, or any other services. It's basically a group of resources that the load balancer can choose from to handle request. So let me give name. I'll give it as pool 1. Select my virtual network where I have my VMs created. Click on Add. Let me select both of my virtual machines. Click on Add. I'll hit Save. So I have my backend pools created. We go to my inbound rules. So the inbound rule defines how the incoming traffic from clients like the users or services should be routed to the backend servers, which is our virtual machines. You can specify things like the port number or IP range from which traffic is allowed, and then direct that traffic to specific backend resources. It's basically how the load balancer knows where to send the incoming request. I'll click on Add a load balancing rule. Provide a name. I'll name it as Rule 1. Let me choose my front end, which I have created just now. So for my backend pool, so the protocol, I'll leave it as TCP. Port number. So this is the port number at the load balancer level. So this is the port to which incoming request will be accessing. So provide as 80. Next, I need to provide the backend port, which is the port at the virtual machine level, which is there in our backend port. So the HTTP request get directed to port number 18. So you need to provide it as 80 for the backend port. And so the health probe, I'll click on Create New. This will verify the health or status of our backend pool resources and direct the traffic request to the healthy resources alone. So this is mandatory for every load balancer service. So session persistent specifies that the traffic from a client should be handled by the same virtual machine in the backend pool. So if the connection gets interrupted due to some reason, the user will still be directed to the same machine if this feature is enabled. So we do not require this as of now, so I leave it as none and leave all the other settings as default. Let me click on Save. Was the inbound rule is in place? Let me click on Next, go to Outbound rule. So an outbound rule handles the traffic that originates from your backend servers going out to the internet or other networks. So you can control things like which IP addresses or ports your backend servers can access. These rules ensure your servers can communicate externally when required. So let me click on Add an outbound rule. I'll provide a name. Choose my favorite IP. I'll leave the IP version as IPv4. So the protocol, I leave it as all. Idle timeout, I leave it as 4 itself. So when it comes to the idle timeout, it refers to how much time you need the session to be open if the user is idle. So I leave it as default, 4 minutes. And the TCP reset and all the other features, I leave it as default. So next we have to select our port allocation method. The port allocation refers to how the load balancer assigns ports on the front-end IP address to allow the virtual machines in the backend pool to make outbound connections to the internet. So when VMs send outbound traffic like accessing a website, the load balancer translates the internal IP and port to a public IP endpoint. So since many VMs might be sharing the same public IP, Azure needs a way to manage the limited number of ports, right? So here I'll just choose to use the default number of outbound ports. I'll let Azure manage that and click on Add. Hit on Next. Click on Review plus Create. So a deployment is completed. I'll click on Go to Resource. And we have our load balancer ready. So let me go to the backend polls. So we have both our machines displayed over here. I have a health probe, which is checking for the health status at port 80. So I have my load balancing rules in place. We also have a feature called inbound NAT rules. So NAT rules are used to map a public IP address to a private IP address within your internal network. So this allows services that need to communicate externally to do so, but without exposing the internal resources directly to the public internet. So it is mainly used when backend services need to make outbound connections but still remain protected behind the load balancer. So here we won't be using a NAT rule, so I haven't created one. We have a normal load balancing rule in place. Can go to the front-end IP from the load balancer itself and copy this. We'll open another tab. Then we'll remove this additional piece of text. And you can see the load balancer public IP is directing the traffic to virtual machine 1 right now. So it looks like our load balancer is working fine. So to further verify things, I will keep refreshing my tab to see whether the load balancer will be directing the traffic to virtual machine 2 as well. So let it refresh. I'll keep hitting refresh for some time. So after refreshing multiple times and basically creating multiple requests, I am able to see this is Neo virtual machine 2. So our load balancer is working as expected. It is directing traffic to both the virtual machines in our backend pool. So if we have traffic reaching out to the front-end IP configuration, the load balancer is successfully able to direct this traffic to our backend pool. So hope you guys found this video useful. So please leave a like and subscribe, and see you in the next one.